Welcome to CS420, Lecture 4. In this lecture, we're going to learn about functions. Now, we've already talked a little bit about functions before in Lecture 2, and you've been using functions for a long time. So you would think this would be pretty easy, but we're going to introduce a new concept that's in functional programming languages that could get a little confusing. So make sure you pay a lot of attention, and let's dive in. Now, functions are a way that we can abstract algorithms, and what that means is hide away the details of how an algorithm happens. Take square root for an example. Now, you probably learned in high school how to take the square root without a calculator, just working out the numbers, and you might have forgotten it by now, but you know what square root means and you kind of know what it does. You might even know that the square root of 25 is 5. So Racket has this square root function built in, and you can refer to it by name. And it's really great because we don't have to know how it works, we just know that it takes the square root of a number. Now imagine that you couldn't call something by name. So whenever you're trying to tell somebody to do a certain operation, whenever they had to do the square root, instead of saying square root, take the square root of that number, you'd have to describe exactly how to take the square root. And let's say that one of those steps is to divide two numbers. And let's say that now you can't even use divide. So now you have to describe to that person how to divide the two numbers. And then you might have some other math that you do, like addition and subtraction. And instead of being able to say, now add the two numbers, you have to describe how to add the two numbers. You can see that without abstraction, things can get really, really complex really fast. In fact, most people don't know the entire details of how a computer works, but through abstraction, they can still get a lot of use out of it because we've hidden away a lot of the details. And functions are our method to do that for algorithms. Now this right here is a way to square a number. We'll just take the number and multiply it by itself, and that squares a number. Now this is not a function, we're just naming something. In fact, if I run this, it's going to say, I don't know what x is. To fix it, we can go define x to be 5. And when we run this, we can now know that square of x is 25. So this only works on this one variable, and it only does it one time. So the two things that we want functions for are, one, to parameterize an operation. What that means is that it can work on more than just one value. Instead of always taking the square root of x, it can take the square root of any number. The second thing that functions do is delay execution. The operation doesn't happen right away. It happens when we call the function later on. So those are the two things, besides abstracting away the detail of an operation, that functions do. Now, before we taught you in Lecture 2, we taught you to write functions like this. And this works. It creates a function, and now remember we got the parentheses around the name of what we had, whereas before we didn't. So this is the name of our function, and it's one parameter. And we can see that this works right there. But we're no longer going to define functions this way. In fact, forget you ever learned that you can define functions this way. What we need is an operator to create a function. Now, you can do this, it's just that this is a little bit limited in Racket on what you can do with your functions, and there's a more powerful way to define functions. And that goes to the lambda operator. Now the lambda operator is named after lambda calculus, and Alonzo Church invented lambda calculus around the same time that Alan Turing invented a Turing machine. And a lambda calculus is pretty complicated, and we're not going to learn lambda calculus, we're just going to learn the successor, this lambda operator that came out of that. So to create a function, we just go lambda. And lambda, whenever you see that, that's I want to create a new function. Now the next step is to list out the parameters that are in that function. In this case, we only have one, but if we wanted to have 2 or 3 or more, we just give a list of all of the parameters. In this case, we only have one parameter. And we'll just take the square of a number. Now, so once again, the open parenthesis here says I'm going to call a function. This is the lambda function that it's going to take one parameter, and we're going to multiply two numbers together, or a number with itself, and square that number. Now, if I just press enter, you see it says, yep, that's a function. The only problem is I never saved this function, I never named it, so I can't use it. But with the lambda operator, we don't have to name functions. We can if we want to, but we don't have to. So for example, I can call this function right away. So what I did is I put this exact function where I created this function, I put that right here. Okay. Now you notice the parenthesis, the extra parenthesis up in front here, and I have to close that parenthesis, but I can also give it a parameter right there. And when I press enter, I get 25. So you might be thinking, wait, what happened here? Well, this parenthesis right here says the next thing better be an operation for me to execute. And luckily, lambda creates the operation. So this part right here, which is the next thing following the parenthesis, creates a function. But we never name it. But that's okay. We create this function, and the function multiplies x by itself. It takes the square of x. And now, because we have this additional parenthesis, that's going to call the function with this as its parameter. So another way that we might do that you're more used to is we can define square to be lambda x like that. So now the lambda is going to create a function and is going to give it the name square. So let me go ahead and run that. And now when I type square, you see that I get the procedure just like I did before. In fact, when I did this, we still get a procedure back. So that's what square is. Square is bound to this operation. So we can call it by putting a parenthesis in front of it, the name, and its parameter. And you see that it squares 6. Now you can probably see that these parentheses might get a little bit confusing. But Racket syntax is really simple. You just need to go back to the basics. So this is really important. Whenever you're having trouble trying to figure out or understand what Racket does, go back to this. Racket always does this. Whenever we have an open parenthesis, it's going to look at this next thing, and that better be a function, and then we're going to have a list of parameters after it. So this is called the evaluation order. This is how Racket evaluates things. Okay? It evaluates all of the sub-expressions. So this right here is one sub-expression. This right here is another sub-expression. Same with this expression up here. This is one sub-expression. This is another. Okay? So what it's going to do is it's going to evaluate this right here and determine what it is. Now, since it's the first one after this open parenthesis, it better be an operation. If not, we're going to have an error. Okay? Then it's going to evaluate this expression right there. And then if there are more, it'll evaluate them. So step 1, it evaluates all of the sub-expressions. So we call it a sub-expression because it's inside of another expression. So it evaluates all of the sub-expressions, then it calls the first one, or the leftmost, passing in the ones on the right, which might be one or more on the right, as parameters into that function. That is the evaluation order of Racket. Now, I will often say it'll evaluate all of the sub-expressions, then apply the leftmost to the ones on the right. What that means is evaluate all of these, then call this function, which should be the first one, passing in all the rest of them as parameters. Both of these are the same basic same thing. The only difference is this expression right here is different than this one. This right here is a name. So we're going to look up the name, and luckily it's been defined, and we're going to find a function. In this case right here, it's a lambda operation. So we're going to evaluate the lambda operation and get a function back. And then we evaluate this. Well, that's 6. That's the number 6. And then we pass 6 into the function that's in the first spot. And we square 6. So I know I went over that in quite a little bit of detail, but if you're ever having trouble figuring out what Racket does, always go back to that. Now I did something a little bit more complex. In this case, we still have 2 expressions in both of these. It's just that the second expression, instead of being a number like we did before, it's a more complicated expression. It's a plus. It's another function call. We're actually calling the plus operation right here. So this right here is a sub-expression. So you might be wondering exactly what do you mean by evaluate? What I want to do is I want to run this. I want to figure out what the result of running that is. Well, the result of running plus 5, 4 is 9, if I can type it in correctly. So the result of running 5 plus 4 is 9. So what Racket's going to do is it's going to evaluate square, look it up, and see that it's bound to a function. Okay, then it's going to evaluate this right here. So plus 5, 4 is going to evaluate that and get 9 back. Then it's going to pass 9 into the function square is bound to. Now the same thing here is going to evaluate this, and lambda creates a new function, and then it's going to evaluate this and get 9 back, and then it's going to pass 9 in for the parameter to that function. Now the only difference between these two is this, we create the function at runtime, whereas this, we create the function beforehand. Another name for this is called an anonymous function. It's a function that's never given a name. And in Java, now you can do it now, but earlier in Java, in the first few versions, every function had to have a name. And but later on, they actually added kind of a lambda operator into Java where you can create functions without a name. But this has always existed in functional programming languages. Now, this is a little bit new to most people taking this class. But it is kind of a confusing concept, but I think it could clear it up. Instead of thinking of functions as functions that you did in Java and operations, it might be better to think of functions as an object. So this is just some pseudocode. This isn't Racket code, but if we were to create a class called square or something like that, basically we would have a field, an integer called x. This is kind of like Java code right here. And then we could have a function called run right here. And it would just return x multiplied by x. Okay. So what we have here, and then we could have a constructor. I'm not going to go into too much detail. But what we have here is a object, or is a class. If we were to instantiate this, we can assign x a value, and then we could call this function, and it would return whatever the square of x was. So I would want you to think of functions, instead of as just operations, think of them more as objects. So functions are exactly like objects. They have their parameters and their operation that they do. So they're like objects that have some fields to them that can be set, and then one function that does an operation. It's much easier to think of functions as this object now, because that's exactly what they are in Racket. In Racket, functions are called first class. What that means is we treat functions exactly the same way we treat any other data type. That's right. Remember when I said creating a class is like creating your own custom data type? Well, now we have a new data type called a function data type. So we can pass functions into other functions. We can have a function that creates a function and returns it back to us. Just like we can pass numbers into functions, and just like functions can return numbers. Now you might see this in the lecture notes. It's a little outdated because they have updated Java and allowed functions to be passed and returned from functions as well. But that's what first-class functions mean, is that we treat functions just like we treat the other data types: integers, doubles, booleans, strings, characters, symbols. Functions are just another data type out there. And again, if you just think of them as an object that has some code inside of it and some parameters ready to get set, it might be easier to see this concept. All right, let's get to the fun stuff. Now this will probably be very confusing looking at it for the very first time. So let's spend some time and really analyze what's going on here. Okay, so compose is going to be a function. Why do we know compose is going to be a function? Well, define takes two parameters. One is a name, and the other is what we're going to bind it to. And you could see that we're binding it to a lambda operation. So the compose, when we write compose, it's going to be an operation. It's going to be a function. And the function is called compose. So we can see it is a function. Now this is a function that takes two parameters. So always, whenever you're trying to figure that out and you see a lambda, just kind of make sure you can, tie things together. This is a function that takes two parameters. Now this right here is the body of the function, of our function compose. So what does our body do? Well, you notice another lambda. Whenever you see lambda, that means we're going to create another function. That's right, we're going to we created a function that creates another function. So, and that's what it's going to return. So when we call compose, we are going to get a function back. Okay, now notice this, the function that we're going to get back is going to be a function that takes one parameter. So when I call compose, it's going to give me back a function that takes one parameter. That parameter is called x. Okay, so what is that function that I get back going to do? Well, see this parenthesis in front of f? Whenever we see an open parenthesis, what comes next? Now that's not the parameter list, so there is a little bit of confusion there, but the body of this function right here, you see this parenthesis? That means this guy right here, f, needs to be a function or an operation. So when I call compose, that means that f needs to be a function. And what about this g right here? Well, notice the parenthesis right in front of him. Oh, g needs to be a function as well. So when I call compose, I need to give it a function and another function as its parameters. And what is it going to do? It's going to take x and it's going to call g. It's going to call g with x as its parameter. That's going to return us a result. Then it's going to call f with that result right there. So let's go ahead and see what we can do with that. To do this, let's first create us a fun function to play with. This one will be a lot easier to understand. So this function right here just adds 2 to its number. We can go ahead and test it out down here. Not too much special about it. If I pass in 5, it returns me 7. If I pass in 2, it's going to return me 4. Okay, everybody add 2 is a function that adds 2 to its input. We'll call compose with add 2 as both 2 parameters right here. Okay, if you see, what I get back is another function. Remember I said compose returns a function. Why do we know that? That's because the body is a lambda, right? What I can do now is define add 4 to be compose add 2 together. Okay, let's run that. And now we have a function that can add 4. So add 4 to 6 and we should get 10 back. Okay, so what is happening here? So let's walk through this step by step. So right here, the very first thing that we're going to do is we're going to call compose, and f is going to be the first parameter, add2. Okay, so you could kind of replace this f with add2 right there. Okay, g is also going to be add2 right here. So you can replace g with add2. All right. So that's going to bundle up a function with f being add2 and g being add2, and it's going to return it. So when I call compose right here, add4 is going to be a function that takes one parameter, and f is going to be add2 and g is going to be add2 right there. So now I have add4 is a function that takes one parameter. When I pass that one parameter in, 6, I'm going to put 6 here. So we can replace this guy with 6. And now we get add 2 to 6, and we're going to get 8. Add 2 to the 8 that comes back there, and we're going to get 10. And that's how compose works. Now here's some more fun that we can have with first-class functions. I have a normal add function, takes two parameters, and just adds them together. Now there's this curried add function that we're going to look at later. I'll show you the first add function. We can just add 5 and 6 together. Get 11. Hopefully not too confusing there. But now let's do this with a curried add. By the way, this technique is named after Haskell Curry, who was a computer scientist, or he invented this concept, and there is a programming language named Haskell, also named after him. So we have this curried add, and we'll do 5, and then we'll do 6 right here, and we get 11 as well. So it's a little bit different. What we do is we call a function right now here with 5, and then that returns us another function that we can call and pass in the second parameter. So currying is by, instead of taking two parameters and calling the function once, we separate it out and we give it a parameter at a time. It does seem like a lot more work to do that. However, one thing that we can do is we can define add 5 to be a curried add, like that. And now we have a brand new function called add 5 that adds 5 to any number. So that's pretty amazing. I don't think you would do the curried. It seems like a lot more work to call more functions to pass in parameters. But let's review what this does. Okay, so we're calling curried add, and we're giving it 5 as its parameter. Okay, so 5 becomes x. We're passing 5 in for x. And what are we going to return? Well, notice that the body of this function, that's what I've highlighted, is a lambda operation. That means we're going to create a new function. Now functions take parameters. How many parameters is this going to take? Well, just one. Now the x that got 5 passed into it, we can kind of replace this x with 5. And in fact, if you want to try to get some help figuring this out, go ahead and once we pass something in for a variable, go ahead and replace it. Okay. Then, so this function gets packaged up and returned. And I'm going to call that function that this returns add 5. Because the x here has been fixed to 5. And now it's a function that we can pass in y, and that will add 5 to any number. Now we're going to talk about arity, or the arity of a function. The arity is the number of parameters that a function takes in. For example, this add has a binary arity, or 2 arity, because it takes in 2 parameters. Now, if you notice, the built-in plus operator can take in a variable number of parameters. So you've seen it called with just 2 parameters, like right here, but now we can call it with 1, 2, 3, 4, 5, 6 parameters, or 20 parameters, or 100, whatever number of parameters. That's called variable-arity. So how do you define a variable-arity function? Well, it's the same way, except notice the difference here, there's no parentheses around the parameters. Notice up here there's parentheses around the parameters. After we have the lambda, there's parentheses after it. That means we're only going to take in 2 items. When we leave the parentheses off, our function becomes variable-arity. So I can call v_add with as many parameters as I want. And it works. Now, what this becomes is a list, and if you go back to lecture 3 and the box and pointer diagrams and a list, the car gives us the first element of the list. Then we take the cutter, that moves to the second half of the list, and then we take the car after that, and that gets us the second element. So I'm really just adding the first 2 parameters and ignoring the rest of them. So that's why it gives 9. I just ignore these, but I get the first 2 parameters out. So that's a variable-arity function. I want to end this lecture showing you a really cool built-in function that uses first-class functions. And that function is called map. Now map is a pretty famous operation, and you find it in a lot of languages like JavaScript and Ruby. There's something called MapReduce, which is really cool. I'm just going to show you the map part today. And I have defined 2 functions, one that adds 1 to a number and one that subtracts 1 from a number. And we can go ahead and try these functions out. So you can see that adds 1 and subtract 1 subtracts 1. So what I can do is I can map add 1. So this is an operation, some function right here that I want to do on a list of stuff. So let's make a list with 4, 5, 6, 7, 8, 9. And what I'm going to do is I'm going to add 1 to each element inside of this list and return it. So you can see the first element is now 5, and then the second one is 6, and so on. We can try this with different numbers so you can see the full effect. And you can see that we added 1 to each element of the list. So we get a list back with 1 added to each element. Now we can also swap out the operation of everything we want to do. Instead of adding 1 to each element, let's subtract 1 instead. And so that's a map. Map takes an operation and a list, and it applies the operation on each element of the list. Now you also might want to look at apply. That's another function that could come in handy when you're doing your homework.